Okay, welcome to Rob and Armando and Terrence and Constance and Brittany and Ari and Tristan and Ivan and Alex and Rachel. All gets moved around, so if I missed one, sorry. This is the regular week one webinar. And this is our first regular webinar of the quarter. We'll have one every week just about. And this is very different than the orientation. The first thing, it's strongly recommend you come live, but it's not required. There will be a secret word later on given, and that's how I do the attendance basically, is I shout out the secret word, I write it down, you write it down, and then you put it in the secret word thing. Can other people hear me? Can you hear me?
Yes.
Okay, so all right. So Alex says there's no sound, so I better let Alex know it's Alex's issue. Alex. Anyone else? And here, check your speakers. Okay, hard to know exactly what's happened on her side, but hopefully she'll be able to hear me eventually. Okay, anyway, thanks for all coming. Let me tell you what we're doing today. What we're going to be doing is chapter 1 and 2. Now, in an hour, there's no way I'm going to get through every little detail of chapter 1 and 2, but I'm going to get some of the major highlights of chapter 1 and 2. And what I like to do is bring in stuff that's going on now instead of stock video, because that you have on the chapter 1 and 2 long videos. So I usually bring in stuff about y'all or stuff about what's going on in the news or something like that. So that's the plan. The main thing for chapter 1 is it's all about how to conduct a survey. So how do you conduct a survey, and what are the issues that occur as we conduct surveys or as people conduct studies? So really important to understand how much can you trust a survey? Did they do their work, or did they not do their work? Were they lazy? Was their sample size a good sample size? Was their sample a good sample? Was there bias? Was their survey question worded well? So that's basically going to be chapter 1. There's a lot of vocabulary in chapter 1. You do need to read the textbook on chapter 1, and you will want to watch the stock video on chapter 1 that I created. The other thing we'll do is chapter 2. Chapter 2, I know this is going to sound like what we're doing in class anyway, but chapter 2 is statistics. And what you may not know, anyone know, what does it mean to say this is a statistic? Can anyone join in and tell me what is a statistic? Since this class is called statistics, must be important, right? The fact, that's a really good guess. Not quite.
A statistic is a determination made by a compilation of data?
Yeah, except the word determination isn't quite the right word. You get almost everything else right. It's actually a number that comes from the compilation of data. So it's a number that comes from the compilation of data. Okay, and that number can be, and we're talking about data as in a sample of the population and not the whole population. So that number could be the sample mean, which is also called the average. It could be the maximum of all the data that you collected. It could be the minimum. Other things that I'm giving you the words that you already know, things like mode, you might have heard that, the most common number. So it's always a number. It could be the percent. So if you asked a yes or no question, then the percentage of people who said yes. That is a statistic. Does that make sense? So what we're going to be looking at is we're going to be looking at different statistics that you collect from data. And it's really important, as you might guess, because the name of this class is called statistics. So you would guess that the word statistic ought to be important. So that's what we're going to be looking at, is we're going to be looking at the different statistics and then how to understand the statistics, at least at a chapter 2 level. The rest of the course, we're going to go deeper in. So that's the idea. So what I want to do, and I'm going to do this all the time, in every webinar is I like to start out if there's any questions about anything. So this is a great time. Again, the big difference between webinars and just readings and watching videos is that you can ask questions, I'll answer them. So this is a good time to ask questions that you might have had as you kind of started out the class. Any questions you might have, and you can either say them or you can put in the chat box. I'm looking at both. I'm hearing and I'm looking, I guess I should say. Any questions from any of you?
I wrote down a question when I was watching the video. I was watching the 1 hour video.
Uh-huh.
And in your video, you said that the best studies are the ones that rely heavily on the math. And so I wanted to ask, does that include historical data that's used to create a statistical probability? Is that likely to be more reliable when you're using historical data?
So the historical versus non-historical is a question that depends on the situation. So for example, if you wanted to find out if people like President Trump, if you use data from 2 years ago, that's very different than asking now. Does that make sense? Okay. By the way, I talk a lot about politics. I'm not going to tell you who to vote for or anything like that, but I'm going to tell you how statistics come in. So it's not really about historical versus current data. It's about how reliable the data collection was. And we're going to be talking about that in chapter 1 is how do you make a reliable data collection?
So maybe let me adjust my question just a little bit based on your answer. I'm thinking more along the lines of cumulative data, like say populations and percentages of populations and changes in housing we'll just use housing as an example, though it's not quite exactly the same thing. But let's say you have historical numbers for populations in the state that date back over a period of years and decades, and you're comparing them as they transition or change due to different influences in the environment or the political whatever.
Yeah, so again, it depends on what your question is. If your question is, what is the relationship? How have things changed over time? Then you have to have historical data. Because you need to find out what it was a while ago, what it is now, so you can make a comparison. Does that make sense, Tina? I'm not sure if that's what you're exactly asking.
Yeah, I'll take it offline because I have a specific agenda and that's not something everyone else needs to know about. But I did want to address like I said, the math involved with collating historical data versus trying to create new data.
Right. And there can be a little bit of math. Math is usually the same. It's a data collection technique can be a little different. The math is the same. I'm just reading through this. Is there a printed textbook I can buy? So I know there is at our LTCC bookstore, and I'm pretty sure you can actually go to our bookstore online and buy it, the printed textbook. You checked and it didn't have one? The library didn't have one either? Okay, of course you can't buy it at the library, but you can check one out. Okay, I thought they had an old one. They need a request from me. Okay, sorry about that. I just thought they always had it. The problem is that our department chair is supposed to be sending that in, and he didn't do it, I guess. I apologize for that. It's unfortunately not my job. If it was, I would have done it. I think you might be able to buy it on Amazon, too. You might want to check that. Yeah, you might want to check Amazon. And again, it's this introductory statistics. You can definitely get the book PDF and print it. That's another way. Yeah, so call for attendance, as I mentioned, I don't do attendance as in checking your names. That takes forever. So instead, I'll do a secret word and you'll do the secret word quiz. That's towards the end. I'll talk about that. Okay, any other questions? Okay, if there's no questions, what I'm going to do, and this is what I like to do at all the webinars, is talk about something new and current. So the good news is I can share my desktop. It never takes long for me to find something new and current. And let me find, I have so much stuff on my desktop. I think it's that one. Okay, so this was some news that came out in today's news. I just checked it like literally an hour before we got in. I always know there'll be something. So in today's news, let me scroll up actually, so you can actually see the title. The first poll after the third Democratic debate shows Biden leading, but Warren is rising. Okay, so I always like to bring in new stuff. And I don't know if any of you watched the debate or not. That happened, I think, late last week. I think Thursday it was. But that's kind of big in the news. Who's our president is important. And in CNN, and you can find this in a lot of different major news stations, they have the first poll. And it just happened. They just released it today. So here is the question. Do they know about all of America? What do you think? Does CNN know how America feels? Any thoughts? Webinars usually last between an hour and a half, Salvador, by the way. Okay, right. They definitely don't. I know they didn't survey everyone in America. How do I personally know they didn't survey everyone in America? I know for sure.
Talk to you.
They didn't ask me. Okay. Did they ask any of you? I've never had anyone say yes, but you never know. Maybe this time. Okay. So far, no one got asked. Okay. So they definitely didn't ask any of us, right? Okay. So now the question is, let's look at this. In the article, we have a new NBC Wall Street Journal poll out Tuesday finds that the President Biden leads the field in the first national polling after last week's Democratic presidential debate. Elizabeth Warren has risen to hold second place in her own. In particular, we see that Biden has a 31% in favor, or going to vote for him, whereas Warren has 25%. So, are these numbers reliable? And that's a big question. It is the big question of statistics. Is when you collect a sample, they clearly did not do a census. Census means everybody, and I know personally, and so do all of you, that they didn't do a census because they didn't ask any of us. So they did a sample. So the question is this a reliable sample? Is there any questions on the idea of the big question of the chapter? Okay, so is this a reliable sample? And that's a big question. It's hard to know exactly. Okay, they do a margin of error. I'm going to talk about that in a few weeks. That's not today. Okay, but they talk about, in terms of the poll, who do they ask? And if you scroll a little bit, I thought they gave it. Okay. They don't tell you, but if we click that poll, now we got some interesting things. Now you can actually see the poll. So it says 506 Democratic primary voters, including 278 respondents with a cell phone only. Okay, and by the way, 13 through 16, this is a very recent poll. This is not historical, by the way, Tina. This is a very recent poll. So one question is, 576, do you think that is a big enough sample to get good information if they did everything right? Okay, Salvador says it's a pretty small sample compared to the population. Okay, one of the things that we're going to learn later in the class is that the compared to the population doesn't matter. And we'll see that in another day, is that if there's 300 million people in the country, or there's 100 million people, or 50 million people, it makes no difference. You still need the same sample size for good, reliable data. Even if there's 100,000 people, you still need the same sample size. Kind of a standard sample size for a yes-no question, this is a yes-no question, are you going to vote for Biden? Is basically a yes-no question. Standard sample size is a little over 1,000. So I look at this, and actually they're kind of low on the sample size, 506. When you said small, I wonder if you were thinking about over 1,000, or were you comparing it with America? My guess is most of you were comparing with America. That's not necessary. You want to look at it, really compare it with 1,000. So it's a little bit small. It's a little bit small, but not because there's so many Americans, it's just because it's not over 1,000. Now the next question is, do we have a representative sample? Okay, here they talk about the survey, and they have all kinds of breakouts and primary only, etc. What about when your total group isn't 10,000? It turns out if the total group is 20 times more than 1,000, so 20,000 or more than 1,000 is always okay. That will get another day, not today. Okay. More importantly is, it turns out the way they did this survey is that they did a telephone poll. And they surveyed people. Is that a good way of getting a good estimate of the population of voters who want to vote for Biden, or want to vote for Warren, or want to vote for Sanders, or the rest of them? Okay, do you think a telephone survey, calling people, and they probably did random dialing, which means, and that's easy, you just pick a number and call. Is that a good way of doing it? And are there any issues? Any thoughts? Any thoughts about whether there's issues with that? Okay. Yeah, so the problem is that there's what's called voluntary response bias. Okay, so those words are important, you should know those. So voluntary response bias means that people can choose whether to respond, and there are going to be some types of people, special type of people, who respond to a telephone survey. And in fact, how many of you have ever not responded to a telephone survey? Click you've not responded if you've ever been one of those that just didn't respond. Okay, you'll notice all of you probably. Okay, all of you. So all of a sudden we got a big bias. We're only getting the people who respond. Okay, I've also been a non-responder. Okay, and I've been a responder, by the way. Okay, but you're only getting the people that respond, and because of that, you're getting a very special kind of person. The exact type, I don't know for sure whether they're more likely to vote for Biden, or more likely to vote for Warren, or more likely to vote for Sanders. But I will tell you that the ones who respond are less likely to vote for Trump. How do I know that? The key is I watch things. I'm a statistician, so I really notice stuff. Any ideas? Okay, what happened almost 3 years ago? What was the big study and survey? Okay, if you go to your history, what did all of the polling data say just before the presidential election last time? Who was going to win? Hillary. Okay, they all thought Hillary was going to win. Okay, and the reason that they got it wrong was voluntary response bias. Okay, I have no doubt that it was voluntary response bias. Okay, and again, I can't prove it, but I have been watching statistics forever. Okay, most of my life. So I know that was voluntary response bias. Voluntary response bias is a problem. So now you want to think about, how do you overcome voluntary response bias or other biases? Okay, and by the way, voluntary response bias doesn't just mean that some people don't answer. If the poll, instead, if you did a telephone survey and you asked, what is your blood type? And a lot of people hang up and a lot of people answer, there's probably no voluntary response bias. Any idea why? That's my guess. Any thoughts? Okay, it's not about private. My guess is that I don't think your blood type has anything to do with whether you answer a survey or not. I'm O positive, and because I'm O positive, I'm more likely to answer a survey. I doubt it. Do you agree with that? Okay, because studies have shown that your blood type has nothing to do with your personality. Okay, they actually have done studies on that. So voluntary response bias means that because of who responded, the type of person that responded, you're going to get skewed data, biased data, either higher or lower in the percent if you're doing a yes/no question than you would get in regular questions. Okay, so again, not only do you want to say that people can choose yes or to reply or not, but also the people who reply have to be different in respect to the survey question than those who don't reply. If they're not different, there's no voluntary response bias. Okay, and I cannot tell you, I'm not sure about the Biden-Warren-Sanders idea. I don't have a good feel for that yet, whether that's got voluntary response bias. I know Trump does so. Okay, it's much harder with the Democrats, it turns out. Maybe you guys know better than I do on that one. Any questions on the idea of voluntary response bias? Okay, sometimes when you're doing a study where you're collecting data, there is no issue with voluntary response bias. And you can come up with one where it's never a problem. Any ideas? Okay, I'm not seeing it. Maybe I'll tell you. Okay, the instructor demands it. Okay, right, and that's one. Okay, so it's not quite demands it, it's a cultural thing. I'm going to call it culture. It's not usually demand. Is that if you're in, especially a face-to-face class, and a survey is handed out in your class, you're going to answer it because that's the culture. Why not? There's no reason not to, especially if it's not that personal. Okay, so if I go and hand out a survey saying how many units are you taking, everyone is going to fill out that survey. Do you agree? So that's an example of where there's no voluntary response bias. Another example where there's no voluntary response bias is, let's say you're a biologist. And let's say you want to find out how tall the average pine tree is. Okay? And you measure all of the pine trees that you study. There's no voluntary response bias. The tree isn't going to say, don't do it to me, right? So there are sometimes, if there's no person exactly, pine tree can't hang up. Okay, so there are a lot of studies where it's not an issue. So it's not always an issue, but it is on telephone surveys. Pretty much always on telephone surveys, okay, or almost always. So now you want to think, if you want to deal with this voluntary response bias, then there's different methods of doing it. So if you wanted to conduct this, let's say you had a good amount of funding and you wanted to conduct a study to find out about registered Democrats, whether they favor Biden or Warren or Sanders or one of the others, you have to decide, how are you going to conduct that study? And how are you going to get a representative sample of the population? Any questions on the idea there? And there are different techniques to do it. The number one technique is called stratified sampling. And the way you do a stratified sample is you identify where you think the biases might lie. So for example, you might say, well, there might be a bias that more women might be supportive of Elizabeth Warren because women might identify with a woman. Okay, I don't know if that's true or not, but it might be. Do you believe that could be true? So then what you do, even though you could have voluntary response bias, and maybe you're going to have a whole lot more women answer the survey than men, or more men hang up. I have no idea, but let's just suppose more men tend to hang up. The way you deal with that is you do stratified sampling. Okay, stratified sampling has a set of things that you have to do, and I think I want to show you those things. So I'm going to reshare, and I'm going to type those out so you all know the different things that you have to have. Let me find it. There we go. Should be there. There it is. Sorry. All right. This is pain, so I can actually write things. Okay, so there's a step-by-step process, and you must follow the step-by-step process whenever you are doing, oops. There we go. Whenever you're doing stratified sampling. So first step, identify the strata. Okay, so in the example I just gave you, the strata's gender. Okay, you got your male and your female. You might also think maybe ethnicity means something when it comes to the survey data, and that would be strata. Age could matter, okay, or maybe age groups, maybe millennials versus seniors versus whatever. So whatever strata, you need to identify what you want to do. Step 2, research the percent of each type. So then you can go on, and that's often easy. You could probably get online pretty quick and find out the percentage of registered Democrats. How would you find that data? So if you want to find the percentage of registered Democrats that are women, I think I could find that in 10 seconds by typing the question in Google or asking Siri. Okay, that stuff is known, and a lot of times it is known. By each type, you mean type of strata. So that'd be like male, what percent are male, what percent are female? Okay, if you're doing ethnicity, what percent are Caucasian, what percent are Hispanic, what percent are African American, what percent are Native American, what percent are Asian, what percent are other, something like that. So you go and you research it. That's usually available. It's usually available. If you're doing, if you're publishing, you need to make sure that you cite your sources. But it's usually not that hard. Nowadays, researching is much easier than it used to be. You just ask Google. Okay, and you can usually find a pretty reliable source. Okay, number 3. Multiply the percents by the sample size to establish quotas. Okay, so let's suppose we found out that 58% of people that are registered Democrats are women. Okay, by the way, I'm making that up. I have no idea what percent there really are, but it might be something like that. All right, so you multiply 58%, you take 58% of your sample size. Do you remember what I said, what a good sample size is for a good yes or no kind of question? It's kind of a target. And you remember? 1,000. Yeah, around 1,000, and 58% of 1,000, I could do that in my head, is 580. Okay, so the sample size, again, is the 1,000 that you intend to be able to do. Sometimes you have to do less because you only have so much time or so much money to be able to do it. Sometimes you do more because you have more money and time. But that's something that is determinant on your finances, your time, your resources. The established quotas, again, are the number of each type you are going to be surveying. So if, as I mentioned, there are 58% women Democrats, then that would be 580 women and 420 men. And those are called your quotas. Your next step is to survey that many of each type. Step 4 is definitely the hardest step. Step 1, 2, and 3 usually takes you 10, 15 minutes. Step 4 could take months. Surveying 1,000 people takes a long time. Or it could take a lot of money because you're going to need a team of people to do it if you don't have a lot of time. So that is stratified sample. Any questions on this? Okay, The good thing about stratified sampling is you can eliminate certain suspected biases. Like you can eliminate gender bias. You can eliminate bias based on ethnicity. You can eliminate age bias. So you can eliminate biases that you identify by the type of person. Any questions on that? Okay, you can't usually eliminate the voluntary response bias with this kind of method because people are still going to hang up on you. Any questions on stratified sampling? Okay, so that's one type. Let me give you another type of sampling. Let's suppose you wanted to survey students at our college. So example, those you survey have to be 55% women. 58 is what I said, but yeah. So in particular, you decide your sample size, you multiply that by the percent, and that's how many women you ask, and then you do the same idea for the men. It'll be a different percent. Does that make sense? Okay, so let's suppose you wanted to survey students on that attend Lake Tahoe Community College. And you all attend Lake Tahoe Community College by definition. Even if your main college is somewhere else, you're all in my class. So you're all LTCC students. All right, so then there is a way of getting rid of voluntary response bias because an instructor can bring in the survey and the students are going to respond, which is kind of nice. So now we want to find what's a good way of surveying to get a representative sample of our college. And the way you would probably do that for our college is different. Stratified sampling probably can be done, but not as important. Instead, what we do is something called cluster sampling. And let's do it in green. Okay, so cluster sampling is nice because it's a lot easier. Because you can go and you can survey everyone in a classroom. Okay, you don't want to just do one classroom because that is very biased. So for example, if I surveyed students and the survey was something like, how many days did you spend at one of the Lake Tahoe beaches? And I asked you guys, and I wanted to get a representative sample of Lake Tahoe Community College. What's wrong with that? Any thoughts? Okay, there's a big bias if I just asked this class. It's very not representative, and how come? Any thoughts? Yeah, this is an online class, and more than half of you aren't even from Lake Tahoe. You don't live here. So you probably didn't spend a lot of days on the beach in Lake Tahoe this summer. Okay, there's some of you that did, but you're not representative of the population of Lake Tahoe Community College students. So what you do instead is you say, let's identify various types of students. So we are probably about 40% online now. We're actually a lot of online students. So you're going to ask a bunch of classes. And yeah, so Salvador, you probably did not go to Lake Tahoe beaches very often this summer, right, Salvador? My guess you didn't. Maybe never did. Yeah. Okay, I went a lot. But again, so it really depends on who you are. So we would get 40% of the classes should be online. And then there are the regular face-to-face classes here at Lake Tahoe Community College. And that's about 35%. Any guess on what other we got? Here's a hint. I can guarantee that they spent no days at Lake Tahoe beaches. We have a lot of students in that situation. I can guarantee it, 100% sure. Yeah, the prisons. So we have an incarcerated student program and lots of prison students. And they did not come to the beaches because they're in prison. They can't come to a Lake Tahoe beach. Okay, you almost don't need to survey them because you know you put a 0 in each of them. So that's an easy one. So what you want to do is you want to get a representative collection. So identify clusters. That represent the population proportionately. Okay, that's something that involves a little research. You got to figure out what proportion is online, what proportion is prison, what proportion comes to Lake Tahoe classrooms, and figure out what that is. Okay, number 2 is survey every individual in each of the chosen clusters. So the nice thing is you don't have volunteer response bias. The other really nice thing is it's logistically much easier. Okay. Oh, Brooke, you didn't go once this summer? I feel sorry for you. Our beaches are beautiful. Okay. So you definitely need to survey every individual, which is really easy in the college setting because we're in a culture where people are going to answer a survey. That's the nice thing. They might lie, and that's a different bias. Okay, but at least they're going to answer. Sometimes you do cluster sampling and you get answers because there's no people involved, like measuring the girth or the width of a tree. You don't have to worry about a tree telling you the truth or not. There's no bias in that way. But how many trees are there? Let's say you wanted to do, California. Okay, there are probably over 1 billion trees in California is my guess. I'm not sure, but that's my guess. So the problem is there's so many trees. If you somehow picked a tree in every acre, because that'd be a nice stratification. The problem with that is you're going to be traveling way too much. So instead, you might pick maybe 20 different acres in California, and that's it. And then at each of those acres, you measure every tree. And you might measure in a mountainous area. You might measure in the Central Valley. You might measure an acre in the city of Los Angeles, for example. You might measure an acre in the desert. So you go to different places that represent California ecologically, and then pick a cluster, which might be an acre, and measure each that. Any questions on that? Let me give you another example of cluster sampling that's done often. Let's suppose you are a manager at a restaurant, and you want to find out how much does the average person tip? Because you want to advertise that to your wait staff. So then you might cluster by time. So you might pick 5 minutes at a dinner time, 5 minutes at a lunch time, 5 minutes at an off time, maybe 5 minutes on the weekend, 5 minutes, make sure you got during the week, weekends, etc. And then look at the receipts for that 5 minutes of time, or maybe an hour, I don't know, it depends how big your restaurant is, of each of those time periods, and that will be your data. And that is different cluster sampling. No volunteer response bias, but you got to find out how you're going to get that data. Any questions on that? Okay, so these are the two of the major ones. Another one I'm not going to write out, but I'll talk about. This one I actually did for a student, a former student. By the way, my rule of the class, if you have a statistics question after you leave this class and you're still a student, I will always help you out. If you have a statistics question and you're no longer a student and it's for your business, I will still help you out, but any guess on what the catch is? So if you're making money on it, any guess? Okay. No, you don't know me well enough. No, I'm not going to share the profit with you. I'm going to have you donate money to our scholarship fund at Lake Tahoe Community College. Okay, Terrence got it. Yeah, and I did that for this former student. He wanted to show his towels, that he had a towel manufacturing business. We're better than the ones made in China. So how do we come up with a sample? We had to take the sample and literally destroy the towels. Throw them in the washer until they weren't good anymore and see how many washer cycles they lasted. So what we did is we did what's called systematic sampling. So he grabbed every 500th towel off of his manufacturing assembly line, pulled those towels and put them into the washer and tested them. That's called systematic sampling. So systematic means you're doing every nth one. Okay, you can't do them all because you don't want to like destroy everything in that you make. Okay, but he wanted to make sure that there wasn't much bias, and there's no bias in doing that. That works really well when things are ordered well. So things like assembly lines, and that's called systematic. Now, systematic and cluster are very different. Cluster, I'm going to go to this class, and then I'm going to go to maybe a music class at night that's face-to-face. And then I'm going to go to one of the classes in the prisons. I'm going to ask everyone in each of those classes. Nothing to do with every, thousands off an assembly line. Do you see they're very different? Yeah, so they're very, very different. Okay, then there's the worst kind of sampling that you should never do if you're trying to get reliable data. That's called convenience sampling. Any thoughts on what that might mean based on just what the word is? Laziness, very biased. Yeah, in particular, you just grab the first people you can find, your friends, post on Facebook, hey, answer my question, let's find out what's up. That's total convenience sampling. You're going to get very unreliable data. They have shown that people who do convenience sampling almost always ask people that are similar to themselves. And that's a psychology thing. So that's called convenience sampling. It's only good if you're just having fun and not making important decisions based on your data. Any questions about these types of surveys and data collection? Okay, those are the main, kind of the main ones. There's some others that I'm not going to get into because I only have so much time. I'll let you read through the book if there's, but those are the biggies that I've just talked about. Okay, and in particular, by the way, in your project, you're going to either use stratified sampling or cluster sampling. You can have a choice, and you have to do this. That's why I actually put this up on for you to see, because that's really important because you're going to have a project where you're doing that. Okay, I'll give hints on the project each time, and then I'll do a whole thing about the project. Any questions on this? Okay, so now we understand bias, we understand sampling. By the way, remember a statistic is a number you get from the sample. If it's a number you get from the whole population, then it's not a statistic because we're getting it from the census. We call that a parameter. So that's another important word. Yeah, that's called a parameter. So there's a lot of language in this first chapter. There's other stuff that I can't get into because I need to get in the next chapter. The next chapter I'm going to do in a little different way. I'm going to share my desktop differently after I get some water because my voice is going to go. I can only talk so much. Okay, so let me do a new share, and this is very important for you to know how to do. Okay, do you guys recognize what I'm looking at? Okay, this is a computer version of the TI-84 calculator. Okay, and I want to let you know this is the newer version of the TI-84. It's really confusing. I was so mad at TI when they did this. So the first bit of production, there's an older version, then they changed the versioning without even changing the name of the calculator, so it looks different. So you can see the newer version in the webinar. Yeah, now we're kind of starting chapter 2. And you're going to see the older version in the videos that are stock videos. That way you'll see both. All right, so what I want to do is I'm going to do a survey of you all, just so that we can get some data. So let me ask you, the question is, how many months ago was it when you took your first college class? Could be 0 if this is your first college class. Okay, and by the way, there's 12 months in a year, so if you're doing a year, you can always multiply by 12. And that's fine. And what I want you to do is put it in the chat box. And if you do years in my head, I can do months. I'm pretty good with that. And watch what I'm doing. I am going to hit the stat button. Stat is very, very important. I'm going to hit the stat button. Then I'm going to hit enter on edit. You'll notice it goes into a spreadsheet program. I'm going to go use my left arrow. I'm going to go up to L1, and I'm going to hit the clear button. Then I hit enter. By the way, I strongly recommend when you are attending these webinars, have your calculator, like that, with you, so you can follow along with me, so you're getting it too. Okay, just a huge, huge warning. Don't ever hit this DEL button. Stay away from it. Tears will flow. Because what that DEL button is, it erases the spreadsheet and then it breaks the calculator. I don't know why TI put that on there. They should not have. But they did, so don't touch that button or you'll be crying. If you live in Tahoe, you'll come to my office in tears and I'll fix it for you. If you're not in Tahoe, it's much harder to explain how to do it. Okay, then I'll have to do it online with you, which is a lot harder. I'll have to like do this and show you, and it's a lot easier for me to just do it for you. So don't hit that DEL button. Okay, so now I've cleared it out. Now I can put in the numbers. So now I have to go up and look what you answered, and let's start typing it in, 24, and then enter. And then the next was 24, a couple of people, 2 years, enter. And then we had 4.5 years ago. By the way, 4 times 12 is 48, plus 6 is 54. So 54, enter. Then 120, 10 years, enter. Let me scroll a bit. 24, 132, 20. 24, enter. 132, enter. 24, enter. 24 seems like the biggie. 5 times 12 is 60. Enter. 19 years. Okay. By the way, 20 times 12, right? 20 times 12, 2 times 12 is 24, times 10 is 240, minus 12 is 228. By the way, I never make you do arithmetic in your head. You're always welcome to use your calculator. I just enjoy doing it in my head. I do that. It helps me fall asleep too sometimes. I'll do like really sophisticated math just for fun in my head and it puts me to sleep. And then 4, enter, 16 years. So 16 times 12, that's a little harder. 15 times 12 is the same as 30 times 6, which is 180, plus 12 is 192. Enter. Okay, 3 years is 36, 54, 49. Okay, 2 with a star. 180. $168. Okay, and then 24 years. First year, I'm not sure what first year means, but 24 years, 25 times 12 is the same as 100 times 3, which is 300. 300 minus 12 is 288. Okay, and then church obligation, sorry about that. So this will be posted on YouTube. All right, so once you have all your data in, the next thing you do is we go back to the stat button. And how do I make the table? So if you watched, I hit stat, and then I hit enter on edit, and it popped me to the table. I didn't make the table. The table is part of your calculator. But I hit stat and then enter. The videos are also online. Okay, so then I go edit, I hit the right arrow to calc. And I want one VeriStats, because we only asked one survey question, so it's just one variable. I hit enter on that. My list is L1 because that was my first row, first column, I mean. Freak list is none. And then enter on calculate. All right, so now what I want to do is I want to look at these numbers. These numbers are statistics or parameters depending on how you look at it. They're parameters if we look at the population as this class, the attendees of this class, then they're parameters. Because I asked everyone, right? I didn't check to make sure you all answered, but then they're parameters. On the other hand, if you consider this data as a representative data of all the online statistics classes, then they're statistics. So let me show you what they mean and how do you read these symbols. So the first, see this X with this little bar on top? The official name for that is X bar. Easy to remember. What it means is the statistics word for it is mean, like being mean, but the kind of friendly word for it is average. So the mean was 87.6 or so. I'm going to round to one decimal place. That's probably enough. Maybe even 88. Let's round to the whole number. It's probably better for this data. So we're looking at a mean, which is an average of 88. So that tells you that the average student took their first class 88 months ago. Any questions on that? Okay, this one, the next two, we'll never use in this class, so we can skip those. But this SX. Okay, first thing, the standard notation is not SX, it's just S. But the calculator uses SX for some reason, don't ask me why, but S is what you're going to see, and S stands for standard deviation. Very important to know that. It is the most important new statistic that we will have in this entire course, and that is the standard deviation. And what it measures is the average or an average distance from the mean that students lie. Okay, I'm going to say an average because it's not quite the formula for average, but you don't have to worry about the formula. What you have to understand is what it means. So we can see that this is actually quite large. It's almost as big as the mean itself. So what we can say, which is not very useful, is that most people are somewhere between 1 month ago and 174 months ago. Okay? I guess that's maybe 2 months ago. If we did 88 and 86, 88 minus 86 would be 82. 88 plus 86 is what, 174. Okay, so somewhere between 2 and 174 months. Is that a pretty big spread or is that not a big spread? What do you think? 2 months and to 174 months. Yeah, that's a huge spread. Okay, so we say this is a very big standard deviation. Any questions on that? Okay, so we have a really large standard deviation because this is a really big spread, and the S is a measure of the spread. Okay, outliers make the spread more. Okay, so outliers mean in this class, it's going to mean you're more than 2 standard deviations away from the mean. That's an outlier. Now, you can't, in this case, have any low outliers because if you take 88 and subtract twice 86, you get a negative number. And it couldn't have been negative months ago that you took your first class. So there can't be any low outliers, but we can take 88 and then add twice 86. And 88 plus twice 86 is what? It's a big number. 248, 260? It's 260. And what we saw is that was there anybody that said more than 260? Okay, do you remember?
Yeah, 88,
yeah,
right?
I think there was one, right? Yeah, I think just Tina was more than 260. So there's one outlier in this case. Was it not? Let's see. 22. No, that's not more than 260. Let's see. Maybe one of the last ones. Oh, there was a 288. There it is. Raphael's 288. Yeah, so Raphael's the outlier. Okay, Raphael's the outlier officially. Okay, outliers are important. Extreme outlier means more than 3 standard deviations away. Okay, it turns out we didn't have any extreme outliers. Okay, oh, there was someone else that was 288 also. I'll trust you on that. Again, I don't remember all the people and all the data, but it happened. You can always go back and look at the data. So we didn't have any extreme outliers, but we did have an outlier or two. Okay, sigma sub x, that's also the standard deviation. Oh, I should mention, this little circle-y thingy, that's a Greek letter. And that means, yeah, we'll get to the max later, I promise. That circle-y thingy is also the standard deviation, but it turns out it's a standard deviation if this data is the census instead of a sample. So if the data is all data, then we use a sigma. The formula is slightly different. You'll see you get slightly different numbers. I am not going to get into the mathematics behind how they're slightly different and why. They're tough. Any questions so far? Okay, N, 19. Any guess on what that means? You might be able to figure that out. Yeah, and so S is the sample standard deviation, yes. Yeah, so N is what we call the sample size. Okay, as Chava said, it is the how many entries, but the words we use are sample size. So the sample size is 19. Min X is 2. I hope you can all tell me what that is. Maybe I'm wrong. Yeah, so min X is the minimum. That is the lowest number that was recorded. Okay. Now comes Q1. Q1 is really important. Q1 is called the first quartile. And what that basically means, especially for a large data set, is that 25% of the answers were at 24 or less. Okay, we'll get to the highest, I promise, but we have to scroll a little bit. But I want to go down and kind of do them in order. So 24% were basically at the 25% was basically 24 or less. So the quartiles break the population into 4 pieces. Okay, so it breaks it up by 4s, and that's kind of how that works. Now we'll do some more. I know you've all been wanting me to scroll down. Now I'm going to scroll down. Med does not mean medicine. Any guess on what med might mean? Yeah, that's the median, and you probably learned that in 3rd grade or something. Okay, I'm not sure when they teach it nowadays. But what that means is that it's the middle answer. Okay, if there's an odd number, of answers is truly the middle. If there's an even number, then there's two middles. You take the average of the two, and that's the median. So that tells us the median was 54. Scroll down again. Q3, any guess on what that is? Yeah, that's the third quartile. Okay, often also called the 75th percentile, which means 75% are at that value or less, 168. And you might guess what the next one's going to be because you all wanted it. Max. So the max X is 288. Okay, and that was the highest recorded data value. So these are the statistics that the calculator gives us. Any questions on these statistics? Any questions? Okay, I want to mention one more statistic that's really important. Let's suppose we want to find out how unusual it is to have only been in college for 1 year before this class. Any questions on that? You kind of have the idea that's probably on the low side. So what we do is we calculate what's called the z-score. And the formula for the z-score is x minus mu, or x bar, depending what you got, divided by sigma. So I'm going to consider this a population. And let's find out what the z-score is for 1 year, which is 12 months, by the way. So notice, and let me write this down so I don't forget. Our mean, I'm just going to round to 88. And our standard deviation, I'm going to use sigma, was 84. And I want to find out what is the z-score for 12. So what I'm going to do is I'm going to go to the calculator, and I need to hit a parenthesis. And I'm going to type x, which is 12. And then I'm going to subtract the mean, which was 88. Close the parenthesis, and I'm going to divide by 84. It's very important to have the parentheses because you need to see how far you are from the mean and then divide by the standard deviation. If you don't put the parentheses, it gives you the wrong answer. Then I hit enter. So my z-score is negative 0.9. So what that tells you is that being here a year is on the low side. It's not an outlier because it's not bigger than 2 or smaller than negative 2. Okay, so it's not so surprising to have been here just a year because the outliers are surprising, but it is definitely on the low side. And that's what the z-score does for you. So z-scores and percentiles are kind of similar, is that they tell you how unusual something is. They're used for different reasons, but they're important. Any questions about this? Any questions? Okay, so let me give you another example. Okay, so negative 0.9 means that it's on the low side. It's negative. Negative means low side. If it's not farther than negative 2, it's not an outlier. So it's not that unusual, but it's lower than the mean. Does that make sense, Salvador? If we got a number like 2.7, then it's really high. If you get a number like negative 3.9, it is extremely low. If you get 0, you're at the mean. So the z-score formula is x minus mu divided by sigma. And x minus mu is on the top. Has to be between, not normal. Normal is a dangerous word. Usual is a better word. You're going to find out we're going to have a whole chapter on what's called the normal distribution, so be careful about that word. And in fact, I wanted to show you something. The last stuff I want to do is I want to get some pictures. Okay, really important to get some pictures. Any questions on using the calculator on this? Okay, so the next thing I want to do is I want to go back And we're going to do some more data. Does it work? Let me do that. There we go. Okay, so I am, let me just do it this way. If you go to the modules, and I go to course information, I go to project spreadsheet resource, I want to go to project spreadsheet resources. And I'm going to go to my Google Sheets. I'm going to click the link. And this is going to take us to a spreadsheet program. First thing I want to do is I want to erase all these numbers. How many numbers are there? I'll just hit the backspace. And now what I want to do is I am going to put some data in. Okay, so maybe you could tell me, let's do another question. Maybe you could tell me instead, how old were you when you first started college? And maybe you put that in your, so 18, 17, 18, 18. Well, there's a lot. I'm not going to put all the numbers in because I don't want to take all your time on this. But it went so fast. 17, 18, and then 18 again. And then we had 33. Then 17, 18, 19. Ooh, that's right in order. Look at that. Seventeen, 18, 19, 18, 17. Get some more. 18, 18, 18, 18, 21. Uh-oh. I want to do it there. There we are. 30, 18. So this is the program I made actually. It's all free. And what this does is it gives you all that stuff also. I don't know if you feel like this is easier than the calculator or not, but I just type in the numbers. What you do have to be able to do is move your eyeballs. And you have to see there's the minimum, the mean, sample variance, which we're not going to talk too much about, sample standard deviation, median, maximum, Q3, and we'll get to that in a bit, Q1. So it has all the rest of the stuff, and it has other stuff we haven't learned yet. It has Z-score, so I can find the Z-score for anything. So if we want to find the Z-score for, say, how about a 25-year-old? You just type 25, hit enter, and there's your Z-score. Okay, I think you'll find it's probably easier than the calculator. Do you agree? I tried to make it easy. Okay, and by the way, this does everything we need in the class. Unfortunately, you can't use it on the midterm and the final because I can't let you have a computer. Okay, but it will work for everything else, and it's required for the project. You have to use a spreadsheet for the project. You can't use a calculator. Okay, so I want to show you some more things. First thing is we have a histogram. And you've all heard, I think is it true? Has anyone never heard of a histogram before? Okay, I'm hoping you've heard of a histogram. I want to mention a couple things about histograms. This particular histogram, notice you have very high frequency on the lows, and then it kind of tails off in the high numbers. You see that? There's a word for that, and the word for that is called skewed right. So it's called skewed right. So I'll put it in the chat just so you can see it. Oh, you know what? It just got, I have to go everyone. Let's try it one more time. There, it's called skewed right. And that means that you have a high left and then it tails off on the right. Hopefully you guys got an idea of what skewed left might look like. Right? That's the mirror image of that. That would mean you have a high right-hand side and then you tail off on the left. it turns out skewed right is very common when it comes to data. Skewed left is less common. Okay, more important, and this is one I'm going to have to, is what's called normal. So to do a normal distribution, let me go new share because I got to draw it. Let me find it. There it is. Let me just erase all this stuff so that I can draw. Let me go to a brush. So normal looks like that. Okay, that's called normal. That's why when someone said, oh, it's normal. No, don't use the word normal. Normal's for this. This is a huge part of this class. So if it's normally distributed, it means that it's not skewed left, it's not skewed right, it's symmetric. Do you see that? So symmetric means that if you put a mirror right in the middle, left and right looks exactly the same. And if it's not perfect exactly the same, that's because I'm not a good artist. Sorry about that. I'm a mathematician, not an artist. So we also call this unimodal. So let me put in some words. This is normal. And that means it's symmetric. And it's unimodal. Okay, if you haven't heard the word unimodal before, hopefully you've heard the word symmetric before. Let's look at least pieces of it. Unit. What other word has that prefix unit? UNI. Yeah, uni means one, unicycle, right? One wheel. So unimodal means one mode. Remember what the mode is. The mode means most frequent. That means there really is. There's no tie for the most. There is a true most. So when it's skewed left or skewed right, those were unimodal also, but they were not symmetric. This is symmetric and unimodal. Okay, so this is normal. Normal is the most important. And the reason for that is very deep. But trust me, it's the most important, and it's really important. We're going to have chapters on this. All right, I want to show you the next one that's also important, another one, and that's called uniform. So when you hear the word uniform, you all know that word. What do you think of? Yeah, it's the same, right? You wear a uniform so you can look the same as everyone else. So that's what a uniform distribution is. That would be, let's put some numbers in. So for example, it might be uniformly distributed between 5 and 20. So that means the high is 5, the low is 5, the high is 20, but in between 5 and 20, everything has the same chance. Okay, so that can happen. For example, rolling a die. That's uniformly distributed. Between what and what? I hope you all know. If you roll a die, that's uniformly distributed between what numbers? A single die. Hoping you know what dice are. Yeah, 1 to 6. So that'll be uniformly distributed between 1 and 6. Now, rolling a die is called discrete because there's only 6 things that you can have. Okay? So discrete means the answer is a number, but you can list all the possibilities. So the answer to rolling a die is discrete because I can list 1, 2, 3, 4, 5, and 6. How about number of siblings? Is that discrete? Number of siblings in your family. Yeah. Can the number of siblings be a fraction? Okay, the absolutely yes. There are 4.5 siblings in my family. Okay, all right. And it doesn't mean I chopped off the, torso of one of my siblings. Okay, dog. I gotta go debatable on that one. But I do have Laura is my is like a half sister, stepsister. She's my half sister basically, and then there's 4 that are blood siblings. So it can happen, but I can still list all the possibilities because you can't have 3.712 siblings. Does that make sense? You can have a half, but you can't have 1/3 of a sibling. That's not possible, by the way. Okay, so discrete means that you can list all the possible outcomes. And if it's continuous, it means you can't. So that would be something like, how much do you weigh? Okay, I weigh 168.1352173 pounds. Okay, and that's just a round off, but my exact weight has a serious decimals, right? You can't list all possible weights. Is that clear? So if you can measure it, typically that's going to be continuous. Okay, if the answer is not a number, like if the question is, which Democrat do you like the best for political office, for president, then the answer might be, for example, Warren. It's not a number, it's a name. Then it's not discrete, it's not continuous, we call it qualitative. So qualitative means not a number. Quantitative means a number, and there's 2 main types of quantitative. Okay. There's also a special type of qualitative, and that's the yes-no question. There's a fancy word for that. I don't want to use it. I'm just going to say yes-no. That's the easiest way. Hopefully you all know what a yes-no question is. Okay, and that's qualitative because it's a word answer, but it's special qualitative because it's yes-no. Any questions at all on the different kinds of data, what you can look at? And while you're thinking, I'm going to go back to the spreadsheet, and I want to show you one more thing. Okay, there's a histogram. You can also do what's called a stem and leaf diagram. And I hope it lets me do it. Sometimes it gets mad. Let me go to stats. I'm going to go to stem and leaf. And there's the stem and leaf diagram. This one's not that interesting. There are 3 outliers, and it just shows the outliers, kicks them out, and does the rest. So notice what you do is you make the stems of 1 digit, and you make the leaves the next digit. Okay, this isn't the best example for a stem and leaf. A good example, by the way, are grades. Because if it has a 9, that means you got an A. If it has an 8, you get a B. Do you see how that works? Because that means you're in the 90s if it has a 9. You're in the 80s if it has an 8. You're in the 70s if you have a 7. So in particular, the way you read this, we can see that there were 3 17s. Do you see that? So the nice thing about stem and leaf is you can get your exact data back. You get all the numbers back. It's a way of organizing the data with a picture and still having the data. One more kind of important data is a box plot. Okay. So again, this isn't the best box plot because there's a bunch of numbers. Let me just throw some more numbers in just for fun, just to make it a little more interesting. Just pretend we had a bunch more numbers. Okay, so now let's redo the box plot with this new data that we've got. Okay, I'm just pretending we have more data. And that looks like a box plot. Okay. Our problem was almost all the numbers are the same, so it wasn't very interesting. Okay, what a box plot does is it shows what's called the 5-point summary. So it shows the minimum, which is this bottom number, 12. It shows the first quartile. First quartile was 18. It shows the median next. The median here was 18.5. Just slightly above the 18, a little hard to read in this. The 36 was the third quartile, and then 88 was the maximum. So it is a picture way of showing the 5-point summary. And just a note, what the main thing of the box plot is the box. That's this red part, and that tells you the middle half. So we can say the middle half is between 18 and 36. And that tells you your typical group. If I go back and look at the stem and leaf again, now you have a much better stem and leaf that you can understand. So Sal, that was the shaded region was the middle half of the data. In this case, you can see, for example, you could definitely see that this data is skewed to the right. You can also look at the data and realize the mode was 18, because see all these 8s next to the 1 and nothing else has like that? Okay. Whereas the histogram, you can't tell the mode. It's somewhere between 10 and 26, but it doesn't show 18. You see that? But the stem and leaf, you can re-get that mode. You can know there was a 55, for example. So you have all the data values and you get the shape of the data. The drawback of the stem and leaf, there's 2 drawbacks. One is number files can't handle it. You know what a number file is? Number phobes, sorry. Number phobes can't handle it. Okay, that's people who hate numbers. So if you're presenting to an audience that doesn't like math, don't use this because they will run away. Okay, so it's good for nerds like me, but it's not good for everyone. The other problem is, let's say you wanted SAT scores and you had all the SAT scores in the country, you couldn't do a stem and leaf because there's too many numbers. So you have to have a number for every single value and it wouldn't fit. So stem and leaf doesn't work for very large data sets. Okay, but this one was fine. It wasn't too large. Okay, box plot. The biggest problem with the box plot is that if you are over 20 years old, most people don't know what a box plot is. Any guess on why people that are, say, 17 know what a box plot is? Any guess? Okay, it's part of the new Common Core standards in America. So have you heard of Common Core? It's now taught in high schools. Yeah, it's a new teaching methods called Common Core standards. They show box plots. Whereas when I was a kid, we didn't learn box plots in school. So the problem is if you're working with adults who haven't taken statistics, if you show a box plot, they'll probably have no idea what you mean. Any questions on that? Okay, I can't give you all the details. I'm going to do my best, but I'm going to give you one very important thing. Okay, yeah, number phobes may not like box plot. They actually, it's even, number phobes are different. Number phobes usually don't even know what a box plot is. They're ignorant. Yeah, so it's not that they're afraid. They just like, what the hell is that? Whereas they probably know what a histogram is. Yeah, Canvas uses box plots for grading. It's not newer, it's newly taught. I've known box plots since I was younger because I'm a mathematician. Yeah, so it's newer in the schools, but it's not a new thing. It's been around a long time. All right, I need to tell you something really important. I have to go back to Sky. And I'm going to tell you something that you definitely have to know. And that is a secret word. And the secret word is sample. Because in statistics, one of the main things you do is you take a sample and you want to make sure it's as random as it gets as you can do. Random is very hard to get. You usually can't get random, but at least you can maybe do stratified sample, or you could do a cluster sample. Given a sample, you can get statistics. And given a sample, you can find a box plot, you can find a stem and leaf, but without the sample, you can't do anything. So the secret word is sample. Write that down, by the way. Please don't forget. If you're here, you should be counted as here. So make sure you write down the word sample. If you go down to your secret word quiz, type the word sample, it'll say 1 out of 1, and it'll show that you've done it. So I'm gonna unshare because we are done actually. It's 7:25. I try to end between an hour and a half. There was a lot to talk about today, so it went a little bit longer on the half side. But I'm done talking about what I have to say. But I'm always happy to answer any questions you might have when I'm done with what I need to say. And you should still read the book. You should still watch the video and work at it, and then post on the Q&A forum if you have any questions about anything. Are there any questions? Can't remember what the book link is. There's a few places. I think the easiest is if you go to the syllabus, which is on the left tab. You'll find where the book link is. It's towards the top. I can show you if you want, if you need that. Yeah. There's other places you can find the book link, but that's the easiest, I think. Okay, other questions? Okay, yeah, you want to see it? Okay, so I'll show you how to get there. I need to share my desktop. And I gotta find it. That was that one. So if you go to syllabus, and it's right here where it says textbook. And it says introductory statistics book. You click that, and there's your book. So hopefully that helped out. So it's easy to find it on the syllabus. There's a few other places it is, but I think the syllabus is the easiest to find. When will you go detail on project one? Probably next week. Next week's webinar, so the week 2 webinar, which will probably be Monday at 6 unless I get like requests where a bunch of people say, I'd rather have it this time. Sigma is a standard deviation for the sample. I'll say the formula. I'm going to say it fast. If I say it fast, it means you're definitely not responsible for knowing it. Standard deviation of sample is the summation of from n equals 1 to from I equals 1 to n of parentheses x minus x bar xi minus x bar square root of all that, all divided by n minus 1. If I say it fast, don't worry about it. That's the formula. More important is you know how to use it in your get in your calculator and the spreadsheet. But there's a formula for it. I have them all memorized, but you don't need to do that. Yeah, so if you don't like the Monday time, post. The reason why I'm thinking Monday is we're doing Tuesday today. Post you'd rather have it at this other time, and if you get a bunch of followers that agree, I agree, I can make it Tuesday instead, because I'm free both times. Or if you want it lunchtime, I could possibly make it that too. The only time I can't make it is late night because I'm tired. I sleep at late night. So Q&A forum is a place to post a request, and if there's a bunch of people that say they want it then I'll make that happen. Okay, any other requests or questions? I recommend either the reading or watching a video before, because you'll understand a little bit more. Okay, those of you who did that, do you agree? Okay, any other questions? Any other questions? Okay, I think these don't go, so I answered your question. Any other questions? Okay, and as I always do, I'll answer questions if there aren't any, and then we'll say goodnight. But I'm happy to keep answering if you have more questions. And you're asking really good questions. kind of the whole purpose of these webinars is so that you have a chance to interact. Okay. So all of you who are saying goodnight, have a good night. And by the way, you can just go to leave meeting and then I know you're done. I usually wait till almost everybody's gone. Okay, thank you all for coming. And I want to thank all of you who are watching this as a YouTube video. It'll eventually happen and takes an hour or two, and then I'll post it. And please post on the Q&A forum if you have any questions. Also post on the discussion forum if you have questions about it. On the project forum, if you have questions about the project, or finding a partner is really important right now. Okay, also make sure that you think about the sampling technique when you're posting on the discussion assignment on sampling. If it doesn't talk about the sampling, then don't post it because someone has to analyze it. If they can't analyze it, then it's not a good post. And now we understand sampling after today. Okay, so Armando, Guadalupe, Brianna, any questions, Brianna? Last chance. So good night, you said. So good night, everyone. Guadalupe, you're good? I'm going to say good night, and I hope everything goes well. Again, please post your questions, and I'll be happy to help you out. So have a great one. I'm going to say good night. What's the best way to study for the class? The best way to study for the class is make sure you stay on top of everything. So when you go to the modules, make sure you do everything that's there. Watch the videos. Make sure you read the book. Make sure that you do the assignments. And make sure you post questions when you have them. That's number one, okay, is to do all the stuff in each module. And lots of writing. Even though a lot of it is just on computer, if you can keep a journal, that helps you. So does that answer? And again, everyone has different learning styles, so I can't tell you for you personally which you should do most of. Okay, have a good night, Guadalupe. And I will, we'll have our webinar next week. I'll post when it is. It might be Monday evening unless I see big requests with lots of people. And then we'll have it a different time next week. So have a good one. Good night.